This lesson looks at density. First, we need to start with the definition of density. So density is how heavy something is for its size. So if we have a look at the right there, we had a block of lead and a block of wood that were exactly the same size and shape, then the lead would be heavier for the same size because it's more dense. To calculate density, we use the equation density equals mass divided by volume. The units of density can therefore be grams per centimetre cubed, so that's the mass divided by the volume, or if you've got larger items, you could look at kilograms per metre cubed. We use whichever unit makes most sense for the thing that we're measuring. For example, if I wanted to calculate the density of a brick with a mass of 1800 grams on a volume of 2000 centimetres cubed, I simply put the numbers into the equation. So here density equals 1800 divided by 2000, which gives us 0.9 grams per centimetre cubed. Now there is one required practical associated with this unit, and it's about finding the density of different objects and substances. You need to know how you would find the density of a regularly shaped object, how you would find the density of an irregularly shaped object, and how you would find the density of a liquid. And we're going to have a look at that in the video clip coming up.
Today I'm going to be showing you the required practical for the particles unit, and that's to find the density of either a regular shaped object or an irregular shaped object. And to do that, we need to know the equation for density, which is density equals mass divided by volume. And underneath there, you see I've written it as a symbol equation with a curly P or rho, the Greek letter rho, equals m divided by capital V. So that's density equals mass divided by volume. So we're going to start by measuring the density of a regular shaped object. So I'm using a little cube here. Now to find the density, we need to know the mass and the volume. So we'll start with the mass. I'll pop that on the balance there. And we've got a mass of 22.12 grams. So I'm just going to record that. So I've just jotted that down there for later. Next, we need to find the volume, and because it's a regular shaped object, I'm just going to measure the length, the width and the breadth and multiply those together to get the volume of the cube. And if I measure along one side, we find that it is 2 centimetres. Okay, and I can just check the other two sides are also 2 centimetres to make sure that's correct, and they're all 2 centimetres. So now I can record that as 2 times 2 times 2 is obviously 8 centimetres cubed. Okay, we've got those recorded there. So finally, I need to do the calculation and find the density. So there's my readings. I've got the mass is 22.12 grams, the volume is 8 centimetres cubed, and density is mass divided by volume. So the calculation is 22.12 divided by 8. And we'll just stick that into the calculator. And we've got 2.765. And then finally, the units are going to be grams per centimetre cubed. So the second object I want to find the density of is an irregular shaped object. So I've just chosen this piece of rock, and as you can see, it's going to be very difficult to measure the volume the way we've just done using a ruler. So if we want to find the density, we need to know the mass and the volume. Well, the mass is the bit that is easy because I still just need to measure its mass on a balance. So we'll pop it on the balance. And this time we've got a mass of 45.94, so I'm just going to jot that down for later. And that's jotted down for later. So to measure the volume, I need something different, and I'm going to use this. This is called a Eureka can or displacement can. And as you can see, it's just a regular metal can, but it's got this little spout coming out the side, which is pointing down. Now, what we're going to do is we're going to stick the rock inside the Eureka can, and it will push water out of the spout. Now, if I collect the water coming out of the spout in a measuring cylinder, I'll be able to measure the volume of water pushed out by the rock, and that's going to equal the volume of the rock. There's lots of things we have to consider here to make sure that we get a really accurate result. So, as you can see, there's water in here at the moment. I need to make sure that that water comes right up to the bottom of the spout, so that the minute the rock starts to be immersed in the water is going to start coming out the spout. So that's my first thing to do. And you have to be a bit careful doing this, because obviously the minute the water starts coming out the spout, we start making a mess. So to avoid that, I'm going to put it in a tray. And now I'm just going to very carefully add water and try and make sure that we go right up to the edge of the spout. So by slightly overfilling it, the water now trickles out, but I now know that the water is exactly at the bottom of that spout, so I should be getting a more accurate result. So now all I need to do is make sure I hold the measuring cylinder underneath the spout so I collect all the water, and then I need to pop the rock in carefully because I don't want anything else to come out, and we're just going to let the water dribble out until no more comes. There'll be a couple of dribbles at the end. Still dribbling. And I think it's about to stop. There. And you see I've left a bit of paper towel there just in case it continues to dribble. So to measure the volume of the liquid, I now just need to read off of the measuring cylinder, and I've got to go to the bottom of the meniscus here. So it actually comes in at 19 millilitres, which is the same as 19 centimetres cubed. And then finally, we just need to complete the calculation. So density equals mass divided by volume, and this time we've got 45.94 divided by 19. And again, we get the calculator out. And divide that by 19. And we get the answer 2.418. And again, we need to put the units on the end. So that's going to be grams per centimetre cubed. And so finally, we can compare the results of the two materials there. Our aluminium there has a density of 2.765 grams per centimetre cubed, whereas our limestone rock is 2.418 grams per centimetre cubed. So the third experiment we need to be able to do is to find the density of a liquid. And we're going to have a look at, for example, the density of water. Now, measuring the volume of water is easy enough because we can just use a measuring cylinder. But we're obviously going to find it slightly more difficult to measure its mass. So here is 100 millilitres of water that I've already measured out, or 100 centimetres cubed. I'm going to stick a beaker onto the balance. Now I need to get rid of that mass, so I'm going to zero the balance now. So when I add the water, I'm only going to be measuring the mass of the water. So let's pour that in. And now we just need to record our results. So we've got 99.85 grams, and we know that the volume was 100 centimetres cubed. So these are our results. Now all I need to do is the calculation. So we know we've got to do density is equal to mass divided by volume. And if I stick the numbers in, I've got 99.85 divided by 100. Again, I get the calculator out. 99.85 divided by 100. Do that in our heads really. Gives us 0.999 to three significant figures. Again, I mustn't forget to put grams per centimetre cubed on the end. And there's our answer.
So let's put our knowledge into practice now and have a look at this past paper question. A student wants to calculate the density of the two objects shown in the figure below. Describe the methods that the student should use to calculate the densities of the two objects. So we can see here that we've got 6 marks that we need to do, but we've also got to talk about 2 different objects. And obviously from the picture we can see we have one regular object and one irregularly shaped object. So to answer the question, if we start with the regular block, we need to include the following information. Firstly, what calculation are you going to do? If you know what calculation or what equation you need, then you can identify what things you're going to have to measure in order to complete the calculation. If you know what you want to measure, then you can work out what equipment you're going to need. So in terms of calculations then, we know that density equals mass divided by volume. Going from the equation, we need to measure the mass of the block, and to do that we would use a balance. To measure the volume of the block, we're going to measure the sides and multiply them together to give us the volume, and for that we need a ruler. Now all we need to do is turn those 3 ideas into a written method. And here's an example of what you might do. So I started off by stating that we need to know the mass and the volume in order to find the density, and I've stated also that density equals mass divided by volume. I've then said what we need to measure and how we're going to measure it. So we measure the mass using a balance and the volume using a ruler. And then finally, I've said that we need to complete the calculation. We approach the method for the irregular block in exactly the same way. I still need to state what calculations I'm going to do, and from there determine what I'm going to measure and how I'm going to measure it. So again, density equals mass divided by volume, so there's my calculation. I still need to measure the mass of the block using a balance and the volume of the block, but this time we're going to use the Eureka can and measuring cylinder. So as you can see here, the first part of the method is exactly the same as for the regular block. I've stated that I need to know the mass and volume. I've stated the equation. I've said I will measure mass using the balance. And then it changes because I talk about how to find the volume using the Eureka can. So here I've mentioned about filling up the water to the spout, placing the measuring cylinder underneath and dropping the block in. I've also explained that the volume of water collected would equal the volume of the block. And finally, of course, I've stated that I need to complete the calculation. And so finally, what I'm going to suggest is that after watching this video, you have a go at writing a similar method for finding the density of a liquid. You've seen how the practical is done, so see if you could write a similarly detailed method. Best of luck.